Welcome to another video. So, in this video, I'll see a new microstrip antenna design specifically for wideband antenna. So, without any further delay, let's get started. So, first of all, we have to open CST Microwave Studio. So, yeah, here is your CST, and I'm using 2019 version, and I already posted 2019 version installation, 2020 version installation, and also 2021 version installation. You can check in the channel itself. So first, we will be moving forward. First, you need to click New Template. So, once you click on Move Template, you will get this Create Project Template option, and you have to click on Microwave and RF Opticals, and we have some set of options like antenna, then RCS, biomedical, optical applications, periodic structures. We need to choose antennas since we are going to design antennas going forward, and we are going to design planar patch antennas. So select that option and click next, and here we have type of analysis. Here you need to choose time domain analysis and move forward, and here we have set of units. So these are the standard predefined units, and you should not change any of the units. Okay, you can go with the same and click next. And now here in this area, this is not mandatory to fill, but if you know what frequency you are going to design, then accordingly you can give any frequency like 2 to 10 or 2 to 8. If you are designing for antenna for a ultra wideband, then I can give 2 to 8 or 2 to 10, like that. Okay, so if you are getting a bandwidth beyond this particular limit, means you can adjust this later as well. And basically we will see monitors like E field, H field, and far field. This will be the basic properties we will looking into, so I choose those three properties as well. So okay, so after clicking all these options, we click next. Now you can give a name for the template design. So I'm giving UWP and finish. Now it's load all the settings part you given, and it will configure it, and you will get this uh, panel. Okay, so the design environment is available now. So as usual, I'm going to design a new design from some base purpose. So first of all, you go to modeling and click on this brick option. I'm going to design a rectangular brick. So I'm clicking on brick options, and just press escape, and you will get this option over here, a small window. So I'm giving here uh, the first layer I'm giving is ground. So okay, so after giving the name, you can give any name. For the identification purpose, I'm giving GNT, so that is ground. And I'm going to give the measurements. So the measurement is like I'm going to give 16 cross 20. So the x-axis I'm giving 16 mm, so I'm giving -8 to 8, and so this is 16 totally. And for the y-axis I'm giving 20, so that is the height. So 20, in a sense, it's -10 to 10, so the total is 20. Okay, and for microstrip antenna we use default height. That is, if I am using copper, and default height, the thickness will be 0 to 0.035. Okay, so that will be the default value. Okay, and coming to the material, we go to load from the library, and I show search for copper. You have to choose copper annealed. Click on load. Okay. And if you wanted to see the preview of the ground, click on preview, and you can see the highlighted area. That will be the shape. Okay, click OK. So the ground is created, and you can see that here inside components and component 1, you can see ground is created. Okay, if you wanted to edit it, you can double click and click on the define brick option. You can edit the values. Okay, so that's all. Now I'm moving forward. I'm going to create the next layer on top of this copper, I mean on top of this ground layer. Again, I'm going to create a rectangular brick. So click on bricks, press escape, and I'm going to give it's a sub in a sense substrate. And again, I'm following the same measurement for the substrate as well. So The width of the substrate is same 16 mm, so minus 8 to 8, and the height of the substrate is 20 mm, so minus 10 to 10. And obviously the substrate will be keeping on top of the ground, so the ground thickness is 0.035 and the thickness of the substrate is 1.6, so it will be adding together, so it is 1.635. Okay, so I need to choose a proper material for the substrate, and here I am using FR4, so you need to search down FR4 lossy. Okay, so then click on load. Okay, that's all. The material is selected, and if you wanted to see the preview, you can see the preview and just click OK. So the material is created, which is highlighted in white color, so which is exactly on top of the ground. Okay, so the two layer is completed, and the topmost layer is patch, which is again I'm creating a square patch. So click on brick button and press escape, and I'm going to give the name as patch, and and I need to give a square kind of patch. So I'm giving that measurement as, that is, the width is minus 5.5 to 5.5. So the total value is 11, and the height I'm giving is from 1 to 9. Okay, so that will be the total height, and these values are I got through the equations, and I do some trial and error methods. So the height will be like from the top of the substrate, and I'm keeping the patch. So the top of substrate, the height is 1.635, and then the height of the patch is again 0.035, so it's become 1.67. So we add together. Okay, so that's it. And again, the material is copper as patch, and your ground is copper, and the substrate is FR4. So and I'm going to see the preview. Okay, the preview is here. So one, two. Okay, so yeah, click OK. Yeah. So this is the patch we designed, and now I'm going to connect a feed to this patch. So again, I'm going to create a rectangular feed. So I choose the brick option, and I give the name as feed, and the measurement is I'm giving 2 mm thickness, so minus 1 to 1, it's become 2 mm. I mean, not thickness, the width of the feed, and the length of the feed is I'm giving 1 to 10, so that is the length of the feed, and the thickness is same as the patch, so it is 1.635 to 1.67, and the same material copper is chosen. Okay, so now you can see it's 1 2. Oh, okay, so the patch goes in the top direction, so it is towards bottom, so it's 1 to minus 10, because I'm feeding from the bottom side. So yeah, of course. And if you wanted to see if there is any gap between the patch, it's not. Okay, fine. So that's it. And if you have any doubts, you can give it as 1.5, so that it will override and there won't be any gap between the patch and the feed. Okay, so I just created the feed. Click OK. Now I need to add these two materials. So in order to add these two materials, I just select the patch first. Okay, and just click on Boolean, which is over the top, and select add button, and just select the second material, that is the feed, then press enter. Now you can see that both the materials are added together. Okay, so that's it. And so we have the antenna, and we have uh, the, I mean, the three layers are here with the patch ground. You can see here, this is the antenna final. I mean, this is the first antenna, first iteration. We do the basic antennas, and next we will do the further. Okay, so let's see the performance of antenna now. This is the basic model. So I just click setup solver. Okay, so yeah, I didn't give any port, so we need to give the port, excitation port. So for that, I am clicking on the rotate button, which is available in the bottom taskbar, and just rotate it a little bit up. Okay, then I need to zoom it again a little bit up. I need to see the feed point. Yeah, now I can clearly see the feed point, this yellow color. Now go to home and just click on macros. You need to select solver, and you need to choose ports, calculate port extension coefficient. Okay, so now you have the default option microstrip. And all right, no, before that, one second. Yeah, if you see this particular port, you need to go to modeling, and you need to pick that face. Okay, choose pick face option, and you just select this end of the opening of the feed. Just double click. Now you can see, if that portion is selected, you will have a dotted red color. Okay, so that means this feed part is selected, opening of the feed is selected. Now go to form and go to macros, and click on solver, go to ports, and select calculate port exchange coefficient. So now this will detect automatically the width and the length of width of the feed, and the height of the substrate, everything. And now you just click on calculate, it will calculate the coefficient. And if you wanted to give the values manually, you can give the value of k manually, but here I am using the automated tool. So click on port from the pick the face. Now the software itself create automatically the ports. So now just unzoom it, and you can see, if you click on ports, you can see that the port is created. Okay, so for the antenna, the feed port is created, excitation port is created. Okay, so this is a very simplest method. And now once you created the port, now your total antenna design is over. You can go to simulation, click on setup solver, and I am running with an accuracy of -10, and just click on start. So now you can see that the antenna start simulating. So just wait for 2 minutes. So it depends upon the system capability, how much processor you are having, how much RAM you are having. Depends upon that, the speed will be varying. So depends upon person to person, but at least you need to wait for 5 to 10 minutes, so you'll getting this antenna design results. So wait few minutes then. Okay, so now you can see that the antenna simulation is completed, and if you wanted to see the result, we can move to one dimensional results, and just click on S parameter. And now you can see the antenna response is that not good that much. So it is going in the upper frequencies. You can see it is going to the upper frequencies, and we don't have an response below a -10 dB. So we need to optimize the antenna design. Okay, and we wanted to see far field, and of course far field also. um, yeah, wait. For f is equal to 2, we are getting 2.2 directivity. F is equal to 5, around 5 dB we are getting, and f is equal to 8, we are getting 5 point something directivity. And of course the gain 0.04 and 0 minus dB, so gain is also not satisfying. So we need to optimize the design. So we'll see the next step now, how to optimize this antenna design. Okay, so now I'm going to do some modifications on this antenna. So the next one is that I'm going to cut away a small, I'm going to create a slot. So so I'm going to create a slot to the left side. So click a break, I'm going to create a rectangular slot. And I given the name as S1, the first slot. Uh, so the dimension is like from -4 to -3.5. So I'm creating a zero point 0.5 mm slot. Okay, the width is 0.5 mm, and y is equal to, I'm giving 329, and the thickness is, since I'm going to create the slot in the patch, so it is 1.635 to 1.67. And just see the preview. Okay, yeah, exactly, this is what I'm going to, this portion is I'm going to delete. And so in order to delete it, you need to choose a different material. So go to library and you need to choose nickel. There are two methods are there. Either you can choose nickel and you can straightly cut away the portion, or you can choose copper itself and you need to subtract from the basic patch from the second I mean slot created. So both are fine. So here I'm going to choose nickel and click OK. It will delete the old simulation result. Now you are getting an option like, from here you need to choose the second last option, that is last option, cut away highlighted shape. Okay, so I'm going to do that. So now you can see that that particular slot is removed from the patch. Okay, so before after this, I'm not going to simulate it, I'm going to do few more modifications. So I'm going to create one more slot. So this time it is S2. I mean the name of the slot is S2, and I'm going to give the dimension from 3 minus minus 3 to minus 3.5. Again, point 3 zero point 0.5 mm thickness. I mean not thickness. The width of the slot is minus 0.5 mm, and the height I'm going this time. I'm going from 6 to 9. Then again the same thickness, that is 1.635 to 1.67. Okay, so since I'm going to cut away the portion, I'm going to create a slot. I choose nickel and just click here. You can see the highlighted portion I'm going to remove. So click OK, select the cut away highlighted shape and click OK. So that slot is also created, and now I'm going to add a circle to this particular rectangular. Okay, so I'm going to wait. So this much is I created. Let's see the performance of the antenna now. I just simulate it. Okay, so the simulation is completed now. Let's check the S parameter. So the return loss is again the same, so there is no much difference. So now I'm going to do one more modification. I just going to select the ground. Okay, so I'm going to do some modification on the ground. So for that, I just select the ground, double click on the ground, just go and define. Okay, so this time I'm going to reduce the size, that is the height of the ground. So I choose the height of the ground as -10 to 10, that is 20 mm. So this time I'm going to choose it as -2 to 10. Okay, so let's see the preview. Yeah, -2 to -2. Okay, yeah, this much only I'm going to keep it. Okay, just click OK. So remove all the results. Yes. So you can see that now it's a partial ground. Okay, so let's see how much will be the result if I am doing some slots in the, will not create some impact. So I'm going to change the ground. So the full ground I converted to the half of the ground. Let's see how will be the performance. So again I started simulation once again. So So the simulation is completed. Let's see the S parameter. So yeah, yeah. Now you can see that we are getting pretty much very where it's a large bandwidth. I hope. Let's see. I need to change the frequency range. I think. See, you can see the start. It's -10. From here, it's going to be more than 8. So next time we will do some for a larger bandwidth because the end is not here. So it is going beyond that. So it will be like around 9 gigahertz. So I will see. We are getting detailed graph in the next simulation. We'll see that. So we can see here the resonant point is around to 4.2, and one resonant point we are getting is around 6.8. Okay, so we'll see for a larger frequency. I'm going to change the frequency. Go to frequency. This time I'm going to simulate it for 3 gigahertz to around 12 gigahertz. Okay, so let's see what will be the result. So now it is again recalculating, uh, so that we can able to see the exact bandwidth of the antenna. So the simulation is completed, and let's see this time the frequency range. So I can see that around point curve marker is placed here, and I'll be placing the second curve marker. So the bandwidth is around 3.3 to 8.6, so around 5.3 gigahertz bandwidth is there, and the resonant frequency I'm getting is around 4.1 and 6.6. Two different frequencies we are getting the resonant frequency. So the antenna is providing a very good response. Let's change some more changes to this particular antenna. And so because you can see that there is only a small slots over here, and if you wanted to do few more changes, uh, we can do that. The next change I'm going to do is I'm going to create a small arc to this particular along to the microstrip antenna. So going to see how that works. So click on for that I'm going to click on cylinder, and I'm going to add it. So S3 I'm not adding, so A1, and the radius, yeah, the radius I'm going to give is 2.7, and the center point of the circle is around x-axis in 2, y-axis is in 1.5, and the thickness is around at the top side, so 1.635 to 1.67, so which is need to move a little bit, I think. Yeah, yeah. So this is design, and I'm going to choose the same. Okay, so I'm going to add it here. So the same copper is chosen, and the preview is here. I'm just click OK. Okay, so for deleting the previous result. Now I'm going to add these two patch. Click on Boolean, then second material. You can see that now we got a modified shape. So now I'm going to simulate it once again. Yeah, let's start. We'll see what will be the result now. Again, this time the calculation is completed, the simulation is completed, and you can see the S11 value. So you can see there are the bandwidth is, I think, again increased. Uh, Let me remove all the markers. So now you can see that the bandwidth start from, let me add a marker over here, minus 10 dB. So from here to here, so around 11 gigahertz we got the bandwidth, so which is a very good sign. But drastically we can see that the return loss, that is the return loss start decreasing. You can see it is above minus 20. So we need more depth over here, the resonant frequency, and here also. So yeah, now I'm going to do another one small addition uh, in the existing design. Let's see that. So for that, use the antenna. So here we need to create another one modification. I'm going to choose a torus. Okay, so and 1 second. So I just selected a cylinder and I give the radius as 6 mm, and at the center point I choose as x-axis 8, y-axis 9, and I'm going to delete this portion. So I choose nickel, and this is a preview, and I'm going to click OK. I'm ready, going to remove the old results. So this part I'm going to delete it. So now the antenna will look like this. Okay, so again I do the simulation. Let's see what will be the result. Now you can see the result. This time I got a wide bandwidth around 3.5 to 8.5. So around 5 gigahertz bandwidth I am getting, and also the return loss I am getting is around minus 30 dB. So the result is very nice, and the resonation point is around 4.5. So the design, so the final modification what I done is like this is the patch shape, and if you look at the ground, I just make a partial ground, and also I removed the central portion of the 2 mm width and 2 mm depth. I just removed. I just created a slot we call a defective ground structure. So I go with I do modification on the ground, that is defective ground structure, and also I created some slots and cut away a few portions of the microstrip rectangular patch. And so this is a final outcome. And also the S11 what graph is like this. And if you wanted to see for 5 gigahertz, and so the direct gain I'm getting is 1.5, which is okay, and the directivity I'm getting is around 3.046. So the directivity also fine. And if you look at the VSWR for the resonation frequency, it is below, it is nearing 1, so which is also good, less than 2. And so that's all. Hope you enjoy this video. So for future new antenna design videos, you can subscribe my channel and share my videos to the other research community. So thank you for watching. See you in the next video.